So here you have to choose the elevation model. You see here, you have here flat terrain. You need the elevation model. You have this bar that says you that there is kind of error because you have to select your digital elevation model, which is the one that we have. So Sikorsky dam. Then it's better to exaggerate a bit the scale, the vertical scale 3. And in order not to see the tiles between the mosaics of the DTM, it's better to enhance the resolution here of 1 order. So you can have OK. And then you can see here the morphology in perspective view. So you can see very well the peak, and you can see very well the relationship between the different units. So it's clear here, and from your map, that we have this event, which is Sikorsky events, that it's one of the latest events that we had on this area. So we have the impact, the ejecta material that you see here to the left, okay, they are mainly distributed on the east, northeast, southwest here, a little bit on the north. Almost no ejecta here. That means that the impact was was lower than 45 degrees probably, and the impactor came from the northwest, from here, because you have a forbidden zone here. After this impact, you have the formation of the smooth plains covering the ammoky material that you have seen here. And the formation of the smooth plains probably take a while, because you have seen, for example, on your map, that there were some difference in color, so different compositional units on the smooth plains. So you can see here that there are different colors within that. So these events was this impact that it was inclined coming from the northwest, and afterward we have this smooth plane in place that after, obviously, the emplacement of the ammoky material due to the impact itself. Outside of the impact, you can see other units. I don't know if you were able to map them, but for sure, you can see that there are some kind of smooth plains with more crater density here that are inside a kind of border here, which is another crater, a little bit larger than Sikorsky one. And you can even so see here that it's even higher than Sikorsky crater, you see. So Sikorsky crater was able to excavate underneath, to cut the former basin and excavate a little bit more, so it's deeper. And here you have a more elevated zone with the smooth plains. This means that first we had this basin, this was infilled, and only afterward we had this Sikorsky crater with its own ejecta and smooth plain on top of it. Anyway, you see that you have even these two small craters that are superimposed to the basin itself. Okay, this means that where afterwards the basin itself, the former crater itself. This means that these two craters were afterwards this bigger one with the smooth plains. Which is the relationship between these two craters and this Sikorsky crater? Actually, we are in the forbidden zone, so it's not clear the relationship between the ejecta and these craters, because we have not ejecta covering this crater. A possibility is that if we zoom in on this crater and we see them on the hill shades, sorry, we can see that there are some landslides. So they are not very ball-shaped or smooth. They are more complex inside them. And there could be someone says that these landslides were triggered when Tsikolsky crater formed. So before this basin, for sure, there were the islands, so a kind of material with a lot of crater that you see here. And also in the base map that come before everything. You have either other events to take into account, and I don't know if someone of you have discussed them, because it depends from your instructor. So please, if some instructor want to add something, please do it. But you see, for example, another important crater that could be mapped separately with a smooth plane inside, and it is after this one, and so forth. Another thing that is visible is it's not so well visible here, but we can see, for example, in the dam itself, that we have on the dam itself, we have a more elevated area to the northeast with respect to the southwest. So there should be something, even the island, that happened before this basin here, and before, for sure, the Tsikolsky crater. But probably we have not a synthetic view, a big view to understand it properly. But here you see quite clearly that we have different elevations between the northern eastern part and the southern eastern one, southern western one, sorry. So if we go back, seeing this, and we want to put number of evolution, so the stratigraphy of that part, we can say that here we can, I don't know if I can put, it's probably, I have to put a bigger, okay. It's not so much good, but okay, you have the first event here, one. Then if we want, we have the second one, that it's this bigger basin here, okay. And we have afterwards probably these small events, the two craters, one after the other. The northwestern one after this one, because you see that there is some superposition. And it's the fourth event. And okay. And then we have the formation of Tsikolsky, which is the last one. Okay. These are the big ones. We have several other in between that I have not considered yet. If you want, we can put another event that is the filling of the Tsikolsky itself. Okay. This is more or less the stratigraphic history, the events that have been done. So I would say, since we have overlapping and cross-cutting relationship, on the base of overlapping and cross-cutting relationship, we can understand the stratigraphic relationships so the relative age of each different event. And so we can construct about on this basis the geological evolution of the area. And when you have mapped the everything, you will be able with different color to attribute even the relative ages of the different areas. The other things is absolute ages, which are much more, so giving numbers, which are much more difficult and will be subjects of future practical activities. So I don't know if Caroline want to add something more. I just want to recall you that I have put, and I can put again, the folder, the cloud folder, into which I would need to have a screenshot in order to certify that you have followed this practical activity. So if you have some questions, or if you want to add something, even Caroline.
Yes,
Yeah, why don't I just quickly, before we get to the questions, let me just quickly add, you know, what Matteo was talking about just now, and what you all were kind of trying to work out in your mapping tests, besides actually using QGIS, is to come up with the relative ages that things have happened. So you have your superposing and cutting relationships to figure out, okay, what things happened in what sequence. And so what we'll talk about in the advanced course, the lecture on Wednesday evening, and then the practical activity on Thursday morning, is how to get absolute ages that you can then use to kind of calibrate your stratigraphic column that you've set up here. So using crater size frequency distributions. And our test area for doing that activity is the same area that you've just been mapping, so it will be familiar to you. Okay, so I think we can just move to the questions.
So if there are questions, please.
Professor, just how to send you the screenshot, please?
You have just to put them on the cloud, and you have the link on the chat. I've put it on the chat. And please write your name, not just Tsikowski crater. Otherwise, I don't know who is sending me things or putting them. So have you had troubles? Have you some questions? As you said, as Caroline said, this will be in any case an activity for the advanced course, so you can even ask for more details there. So can you show us how to create, expand the 3 classes under each of the mapping layer feature? I don't understand well the question, so probably it's derived by some groups. So could the instructor give some hints about it? Are you asking me how to expand the symbology of a given layer? Okay. So
yeah, I think he means your 3 colored items that you have in each of your groups there.
And this, yeah. Okay, I have just 3 color here because I have just mapped the 3 units. I cannot expand them without mapping all other units. Okay. But in any case, when you have you have done your construction map, and you have done with the mapping moon units with their properties, and you see here, and you go to the symbology, you may have, I would say, made the attributes here with the different names, so you can even add, for example, in this case, Sikowska crater inner slope. So I can have one name added here, for example, but in any case, I cannot add a point on the legend because I have not traced anything here. But I can do if I trace something more. So normally you can go to symbology and classify, and if you have in your attribute tables the new values, you can expand the polygons. I don't know if I have answered well, or you are looking for something more. So if you go on the attribute table, for example, here, I want to see my attribute tables of my polygons. We are looking this one. Okay. And you see that I have just two polygons with two values, TSP and TSCP. Since I have no other polygons, I cannot extend my legend. But if I would have had them, I can go here to properties, then symbology, and then I have to classify, indicating the value field that I need. So in this case, GeoUnits. Have I answered, Charles, the question? Okay, thank you. So are there some other points? So if there are no other questions, I hope you have enjoyed your practical activity, and that you have much more time to make more practice with QGIS and MEPI. So I think that there are no, I would say, problems on that, on question marks on that, because in the next practical activity, it is supposed that you already have some practice and you know already how to do. So thank you very much, and we will reconvene in the main lecture room at 2, so you have time for lunch. So thank you very much to everybody.